Hello, and welcome to another Marlin 3D printer tool tutorial. In this tutorial, we will be covering the bed leveling feature and bed surface scanning feature using a probe. The tools you will need today are a pair of pliers, a screwdriver, or any other tool required to level your bed. And obviously, you will also need the Marlin3DprinterTool software. If you are unsure of how to install the software, please click on the following links to watch these tutorials on how to install it properly. First, let's go ahead and start the software. Once your software is running, make sure to input the correct baud rate and input the correct port that your printer is connected to. If you haven't donated to the project yet, a pop-up will appear. Now would be a great time to donate to the project and continue its development. Once you are connected, a whole slew of information will appear on your screen. You can resize the window if you so choose to by moving it left or right. Here I'm moving it over so I can add the direct feed from a webcam so you may see and follow along with what's happening on the actual printer. On the upper tabs of the software, we are going to be working on the bed configuration tab. Before we start, first let's home all the axes of our printer. You'll notice that each corner of our printer is represented in the software. We're going to be designating each corner during this tutorial. You can also input each one manually by typing them in these boxes. The footsteps icon will make your printer move to that position that's input. The Save button will now save this position for that corner. Instead of typing each one in, you can move your extruder with the interface to the position that you want. Once you get to your desired position, use the Pin button to write that position to the software. And make sure you save it for future use. Make sure you do this for all four corners. Choose a safe home position. A good safe home position is the center of your bed. It will allow easy access later to level those screws on your bed. Let's go ahead now and probe the bed. If you use a servo-assisted probe or something like the BL Touch, then answer yes to the prompt. Most of us will be using a proximity sensor and will answer no. The process now begins. It will first home the X and Y coordinates and then go to your designated safe point to home the Z height. It will then travel to each corner you designated and measure the difference between its current position and its safe home position recorded earlier. Displaying the difference in each box. At the end of the bed level, it will return to the safe position, allowing you easy access to your bed leveling screws. Each corner will now display how much adjustment is needed to correct the bed. This adjustment is represented in minutes, much like a clock, where 60 minutes takes a full turn around the face of the clock. 60 minutes here represents a full turn of the screw. This corner here now needs 24 minutes of adjustment counterclockwise, so I'm going to adjust it almost half a turn counterclockwise. Once I'm done making the adjustments, I'm going to run the bed level again. You'll now notice that each corner is almost identical in bed level. Now that your bed is fairly level, let's use the scan feature to scan the surface of your bed. As you can see here, it will give you a graphical representation of your surface in a 3D picture so you can see the deviation better. Here you can enter the number of points to probe in your X direction, your Y direction, and even how many times you want it to probe the surface of each point. I'm going to insert a value of 4 into each axis. This will give me a total of 16 points that it will probe. It will first home the X, the Y, and the Z height and start its probing feature. As you can see, when it gets to each point, it repeats the measurement once because I told it to. At the end of its scan, it will return to the safe home position and show you the results. As you can see here, we leveled off each corner to within a total deviation of 0.04 millimeters, but the surface scan shows huge peaks and valleys for a total deviation of about 0.22 millimeters. A good cause of a deviation like this is bent shafts. Looks like I'll be rebuilding my BigBox printer later. For more tutorials on how to use the Marlin3D printer tool, please check the video description for links. Also, visit our Google Plus community for more help and support with the software.